recording. Okay, 2x minus 2 less than or equal to -2x plus 4. Yeah, those are the special cases actually, yes. So I'll show you how to do this anyway. So that's the question. This is question number 4 if you're following at home on this handout here, right? Linear inequalities review. So I'm going to distribute, right? Get rid of the brackets. So you get 2x minus 4 less than or equal to negative 2x minus 8. That should be your first step. Next step is bring all of your variables over to one side. I'm going to choose to bring everything to the left. So you've got this 2x here. The negative 2x comes over adding. And the negative 4 comes over to this side adding as well. Right, so the negative 2x came positive, the negative 4 came positive to the other side, and notice that nothing flips, okay, because you're just moving stuff around. So you end up with 4x is less than or equal to, and this would be negative 4 here. At this point, you divide both sides by 4, and so x is less than or equal to negative 1. This is just a vertical line and goes through negative 1, 0, right? Like if you're thinking of the boundary line that's going to come out of that inequality, it's going to be a vertical line. Okay, we talked about that at the very beginning, right? That x equals to something is a vertical line. So if you were to graph this, you know, we have x and y. And my scale, if I just use a scale of 1, I'll be just fine. Right, 1, 2, 3, negative 1, negative 2, negative 3. And then same here, 1, 2, 3. Right, from this, we get our boundary line, which is x is equal to negative 1. Okay, so that goes through right here, negative 1. And before I make my line, you always have to ask yourself, is it solid or dashed? And because there is the equal underneath the inequality, this is going to be a solid line. So this is the line x is equal to negative 1, right? And I will just make a little thing here, just arrow going there. It's going to be solid. If you have the equal sign, because this is saying less than or equal to, right? Meaning that the line is included in your solution here. And here I'm going to call this determine true, false region. Right? Determine the true or false region. So you're going to have to figure out, is everything to the left true or everything to the right true, right? And so if one is right, the other one is false. Okay, so this is how we do this. We usually pick 0, 0, right? And notice that 0, 0 in this particular example is to the right of the boundary line. Okay, note that. So we're going to pick 0, 0, and we're going to plug it in to the inequality here that we've just done. And we have 0, right? X is 0 is less than or equal to, and the right side of that inequality is just -1. So there is no y in this case to plug in the 0. And then you ask yourself, is 0, right? Is this true or false? Like basically true or false? And you would have to say that, right, this is a false statement because 0 is not less than -1. So that's false. Okay. And because the test point we picked is to the right of the line, that means that everything to the right is going to be false. So we declare this area here false, and by definition, right, we have to call the right side true. Okay? Because 0, 0, when we tried it, it gave us a false result. That helped us to determine that everything to the right side will be false as well. So true and false never changes, okay? That stays fixed. Once you've determined that, that is it. Shading changes. If I asked you to do regular shading here, you would be shading in the true region, okay? If I asked you to do reverse shading, you would be shading in the false region. I asked you to do reverse, I believe, if I remember correctly. My answer key would have been reverse, I think. So just a light, like don't, some students like scratch out their whole work. I can't even see the graph anymore, right? Like that's not what you're supposed to do. Just shade it, right? Like that. And maybe a little bit darker, right? Like it doesn't, so that it's visible, right? On paper, it looks a lot darker than on the screen there. But this would be the graph of it, right? And you will find out that it's going to be this part here, determining the true and false region is going to be a little bit quicker as we go along. Like I'm going to show you a way to do it really quick. So you could have picked a point to the left as well, any point here, any coordinates, right? If you plug that into the inequality, it would have given you a true answer. The result would have been true. So then, but we always pick 0, 0 because it's the easiest one to work with. Okay, so unless your line is going through 0, 0, right, that's the only time you cannot pick that one. Then you have to pick something a little further away from the line, right, off of the line. And that's how you come up with that. Okay. Any other one that you would like me to do here? Oh, somebody is asking something. Number 6? Yeah, sure. I'll do number 6. So 6, I'm just going to write it down as 1/3 y plus 6 is less than 4. So if I'm in the graphing mode, I know already that this is going to tell me that it's a dashed line. Okay, because of this. Okay. So I know I'm going to keep that in mind. So what I'm going to do here is if you have 1/3 or divided by 3, it's the same thing. Like this could have been y plus 6 divided by 3, right? You're just taking the 1/3 out in front. You multiply this side by 3, and you multiply this side by 3 also. And that gets rid of these two here. So you end up with y plus 6 is less than 12. do not flip the sign because you haven't multiplied by a negative. You just multiplied it by 3, right? It's positive. Nothing changes. At this point, you can already tell that there's no x. It's going to be a horizontal line most likely, right? So y is equal to 12 minus 6. Y is less than or equal, just less than 6. And I'm just going to make a note. Y is equal to 6 is the boundary line, right? BL. I hope that doesn't mean anything that I don't know about, right? These days with these social media, it could be saying something inappropriate, but it's just boundary line, okay? So y equals to 6. We know that's a horizontal line, goes through 0, 6. So we're going to graph it here. I'm going to have a scale of 5 or maybe 2, 4, 6. And just for now, I'm just going to leave it like that, right? I'm going to go x, y. This is 2, 4, 6. We're going through here. And it's dashed, so keep that in mind. If you ever forget that, all you need to do is use an eraser and erase like chunks out of that line, and now it's a dashed line, right? So this is the y is equal to 6 line. So again, this is your boundary. So you need to figure out where is true. Is it above or is it below, right? You need to figure that out. So test point, we call that test point, right? We pick 0, 0 again. 0, 0 is right here. Note that it's below the line. So you plug 0, 0 into this one, or if you really want, if you like a challenge, you can plug it into the original one. It doesn't matter. If you didn't make any mistakes, they should give you the same results. Because just remember, this first inequality is the same thing as the last one here. So we plug in 0 for y. So 0 is less than 6. Is this true or false? And that is actually true, right? 0 is less than 6. So that is true. That means that everything below the line is going to be true. Everything above the line is therefore going to be false. Okay, so I'm going to shade in the false region because I'm doing reverse shading. I will make a note of that because you might look back in your notes and okay. I will tell you this, okay? If you tell me which one the true and the false region is, I really don't care if you did regular shading or reverse shading because you're still, this is what I worry most about, not the shading itself. It's the fault, but you're gonna see that fault shading faults. It's a lot better down the road when you have multiple lines going every which way. So we also did reverse up here, right, on the previous example. If you want to make a note of that. Okay. So that's those are the two that I'm going to do, and then I'm going to move on. And if anything here didn't make sense, or like when you were doing the homework, go back after today's lesson, and it might make a little bit more sense. Okay. Thank you, Jason. And Onar, thank you for asking. Sometimes it takes some brave people to ask, and everybody else benefits, right? So I'm gonna